Hi, everyone. My name is Mike Kruskal, and I'm on the Protobuf team at Google. And today I'm going to be talking about Protobuf Editions, which we first previewed here 2 years ago at this conference. For over 2 decades, Protobuf has powered countless systems. While it's emphasized evolution of schemas from the start through the use of things like unknown fields and flexible schemas, evolution of other aspects has proven a lot more difficult. For example, the wire format itself has had almost no changes made to it since Proto 1, and these changes are extremely difficult to roll out safely. This talk is going to be focused entirely on the evolution of the language and APIs, which motivated the design of editions. While we've been able to evolve our runtime APIs somewhat via breaking changes, it's really disruptive and it's not really scalable to the APIs generated for your proto files. We have been able to make some changes to those by creating ad hoc global options, but those tend to just build up over time and they always keep the bad defaults that we want to remove, cluttering your schemas. For the proto language itself, there's been two major evolutions in its history. There was originally a Proto 1 internal to Google before we created Proto 2 and released that to open source in 2008. We then later created Proto 3 and released that in 2016. Both of these evolutions were drastic changes to the language where we really had no migration plan in advance. The migration from Proto 1 to Proto 2, for example, was an incredibly painful multi-year effort that still isn't 100% complete. Proto 3, on the other hand, was launched with an explicit goal to not replace Proto 2, mostly to avoid the painful migration we had just kind of finished. And it ended up bifurcating the ecosystem. In creating Proto 3, we added and removed a bunch of things from the language in a backwards incompatible way. For example, field presence was made implicit, enums were changed to follow open semantics, repeated fields were packed by default, strings were made more reliably UTF-8 validated. We added maps, JSON, and replaced extensions with any, and a lot of these we backported to Proto 2. But we also made quite a few mistakes in Proto 3, some of which took us years to reverse, and a lot of which we still haven't. In 2020, we decided to fundamentally change Proto 3 by putting back the explicit present semantics of Proto 2 using the optional keyword that we had decided to originally remove from the language. This was notable because it demonstrated that we could make backwards compatible changes, but it required a significant amount of work to actually land. Every Proto C plugin now forever needs to advertise whether or not it supports this new feature. And new files that use Proto 3 optional no longer work with older versions of the compiler or plugins that don't advertise that support. We had a lot of other changes we wanted to make, but we also wanted to be able to improve the language more gradually. Introducing something heavy-handed like Proto 4 and expecting it to be final forever would have just repeated our past mistakes. So our solution to this problem was Protobuf Editions, which was inspired by Rust Editions. And it's a new framework designed for controlled extensible evolution of both the Protobuf language and generated code. Instead of a new monolithic syntax version like Proto 4, Editions are more of a framework for configuring individual language features at a much finer grain level. They're designed with backwards compatibility in mind, so there will always be a migration path from older editions to newer ones. You can upgrade your protos to the latest edition to use the newest features, but also retain old behaviors when needed, even if they're no longer the default. By pushing the control down to fine-grained features, this design allows for precise incremental upgrades. New proto files can use the latest edition with the latest features and defaults, while remaining completely compatible with files still on older editions. Those older files can also be incrementally upgraded on their own schedule by overriding features as needed to restore old behaviors. Here's an example migration that shows how a Proto 3 file can be upgraded to Editions without changing any behavior. We start with a simple Proto 3 message with two string fields. One of them has been marked optional so that it has the explicit presence tracking behavior like in Proto 2, and the other has the implicit presence behavior that Proto 3 uses by default. The main difference between these two things is basically just whether or not we generate hazards for the fields. In additions on the right, instead of specifying a syntax, each proto file now explicitly declares its addition, where here we've used our first edition 2023. This declaration locks in a specific set of default values for every feature on everything in this file. The default field presence behavior in 2023 is explicit, like Proto 3 optional. So in order to keep the implicit presence on field A, you would need to specify a feature override like we've done here. Features are specified just like ordinary options. The main difference is simply that their default values, when they're not set, can vary between editions. In an alternative scenario, if you had a proto with a lot of implicit fields, you might want to override field presence at the file level, specifying a new file-wide default. In this case, you would then specify the feature override on field B to set it back to explicit presence. This highlights the lexical scoping property of features, where any feature overrides will change the default for everything within the containing scope. So features set at the file level will override the default value for everything within the file, and features set on a message will override the default for everything defined within that message. This example also demonstrates one of the language changes we made in edition 2023. The optional keyword was removed from the language, again, and we restored the Proto 2 semantics of tracking field presence by default after realizing a bunch of different problems with implicit presence. Another example of how we can use additions is for API evolution. This is done using language features where any Proto C plugin can manage their own set of features specified in a proto file that follow the same set of rules as the global ones. So here on the left, you can see we import cppfeatures.proto, which contains our C++ language feature definitions. In our first edition, we released the C++ string type language feature as part of an ongoing optimization effort. Previously, the accessors generated for string fields would return string references, like what's shown here for field B on the right. And this API is actually a little problematic because it forces us to store the field in memory as an actual stood string object, and it leaks implementation details and prevents us from doing all kinds of optimizations under the hood. By opting into the new view feature, these accessors will start returning the more opaque string views, like for field A, and it'll give us the freedom to optimize our internal memory representation in the future without actually breaking anyone using this feature. In our next edition, which I'll discuss in a bit, we flip the default value of this feature to view after an internal migration. So after upgrading, you would just need to switch where the feature overrides are. Field A would no longer need an override because the default is now view, and field B would need to be overridden back to the old string behavior. And the result is that you would get the exact same gen code. The power of the additions framework comes from being able to explicitly enable or disable individual features within a chosen edition, giving you fine-grained control over your schemas. While we've picked defaults representing our recommendations and future direction, any Proto 2 or Proto 3 behavior can be represented in additions with the appropriate set of feature overrides. With Protobuf Editions comes a new commitment of stability from us. Once an edition is officially released, all of its defined behaviors are frozen outside of minor bug fixes. This means that if you have an edition 2023 file, its generated code and runtime behavior will remain consistent even as we release newer versions of Protobuf. This consistency is guaranteed for the entire supported lifetime of that edition. Any new features or changes to default behaviors will only ever be introduced in new editions. This puts you, the user, firmly in control. You get to decide when you adopt new capabilities by explicitly updating the edition declaration in your proto files. Our goal here is to eliminate the fear of unexpected breakages and also the complexity of our protobuf releases. You can develop with confidence knowing that your proto files will continue to behave as expected without changes as you update to the latest version of Protobuf. One thing that might not be obvious here is how Proto 2 and Proto 3 fit into this new framework. But for all intents and purposes, both of them are now treated as special historical editions themselves. In fact, our edition enum has special values for Proto 2 and Proto 3, and almost all of our internal code treats them just like any other edition now. They even have their own set of default values specified for every feature. Just like the explicitly numbered editions, their behaviors will now be completely frozen, and they will continue to receive long-term support. This means that bug fixes, performance improvements, and compiler updates will still apply to all of your Proto 2 and Proto 3 files. But the cost of this stability is that you won't be able to use any new features we release without upgrading to the latest edition. There won't be any forced migrations, though. You are absolutely safe to continue using your existing Proto 2 and Proto 3 files for the foreseeable future due to our long-term support guarantees. It is important to be clear, though, that long-term support is not the same as eternal support, and like any software, very old editions will eventually reach an end-of-life phase. However, this process will always be transparent, and we are committed to providing clear deprecation policies and ample notice years in advance before any edition reaches its end of life. We haven't yet set any timelines for deprecating old editions or features, but before we do, we will be providing ample tooling and documentation to help you transition off of them. Since our initial public release, editions have undergone a massive internal rollout at Google. This wasn't a small-scale test. It was a full migration across our vast code base. We have successfully migrated hundreds of thousands of Google's internal protofiles to Edition 2023, and this effort tested and validated the framework in real-world, high-performance scenarios. Our internal use has ensured that our compiler and the various language runtimes are robust and fully functional under editions, and we've ironed out a lot of kinks and edge cases throughout this process. It also reinforces our stability guarantees for the open source community. This internal migration was carried out using Prototiller, which is a tool we've developed to programmatically transform proto files. And while Prototiller is currently still internal only, we're actively working on getting it into shape for public release with the goal of making future migrations as smooth and automated as possible externally as well. Compared to the Google 3 monorepo, where everything runs at the same version, the Editions framework in open source ecosystems has a few complications. The main difference comes from the version skew between the various components that need to interact with your proto files. There's 4 basic different types of component that need to be considered here. The first one, of course, is the Proto-C compiler itself. To use any specific edition, you'll need a version of Proto-C that actually understands what that edition is. For example, our first edition was released in Proto-C version 27, and it wouldn't be recognized by earlier versions. If you try and give an edition 2023 file to Proto-C version 26, it'll give you an error saying it doesn't understand the syntax. So when you upgrade your Proto to a new edition, it will suddenly have a new minimum version of Proto-C that users can actually use to build it with. There's also the language generators that generate code for your protos, which can either be Proto-C plugins or the generators built directly into Proto-C itself. These generators all need to explicitly advertise their edition support to Proto-C. And if you try and compile a proto file with a plugin that doesn't support its edition, Proto-C will then give you a clear error message indicating that you either need to update your plugin or get the owner to add support. All of the plugins advertise a minimum and maximum edition version that they support. For both of these types of plugins, Proto-C and the generators, users should tend to prefer the latest versions so that they can always build protos from all editions. On the other hand, proto owners should typically hold off on upgrading to an edition until they're willing to drop support for older releases from before that edition was released. Our releases generally stay in support for 1 to 2 years, so staying 1 or 2 editions behind to continue working with all supported versions of Protobuf would be a reasonable thing to do for protos with a lot of consumers. For example, almost all of Google's public APIs are still on Proto 3 for this exact reason. Related to the generators are their corresponding runtime implementations, which usually have coordinated support windows. You can't really expect arbitrarily old versions of the runtime to understand future gen code as changes are made, but the specific guarantees may vary by language. For all of our languages that we publish, we've specified that we never support gen code produced with a newer version of the generator than the runtime being built against. And we've actually started adding poison pills to enforce this in all of our languages. So with that policy in place, you can actually be sure that any supported runtime will always know about the edition your proto uses if you are actually able to generate code for it in the first place. Another issue that can pop up with runtimes is if you have old binaries in your system somewhere that have old versions of the runtime and gen code built into them. If you have protos that are used to communicate with those binaries, you might be worried that upgrading those protos to a newer edition might break something. But because editions are designed to be backwards compatible, you would typically do this upgrade in a behavior-preserving way by setting the appropriate feature overrides. This means that the upgraded proto would be wire format compatible with the old one, and any code still running on your system will continue to work just fine with the serialized bytes it receives from the newer proto. The final component to consider is third-party tooling. Any tools that leverage our plugin framework would have to advertise their edition support windows, just like the language plugins, and they would behave the same. If an unsupported edition is passed to these plugins, Proto-C will report an error. In fact, many of these types of plugins, especially the RPC-related ones, don't actually care about any of the features we've released so far. So adding support may be as easy as simply flipping the right bit to advertise that fact. The more complicated cases are those tools that parse proto files directly without using any of our libraries. These will also need to be updated to understand the edition syntax and its features, but the failure mode is a lot less predictable because we don't control anything about what they're doing. We have published documentation for tool owners on how to implement edition support, though, so we encourage you to check with project maintainers if you're using any of these tools. Finally, we're excited to announce that our second edition, 2024, is officially released and available as of 2 weeks ago. While our first edition was primarily focused on simply unifying Proto 2 and Proto 3, Edition 2024 actually makes some incremental improvements. We kept the changes fairly limited, targeting specific user pain points that fall into 2 basic categories. The first is language-specific changes that only affect a single language. One example of this is we added a Java feature that allows you to generate larger enums that work around some size limitations in the language. We also made a few Proto-C front-end changes, which are defined as changes implemented entirely in the Proto-C binary itself and don't require any changes to language plugins or runtimes. One example of this is that we added a feature to enforce our naming style guide in proto files as you build them with Proto-C. As a result of this scoping, Edition 2024 should be a lot easier to implement for third-party tools that have already added support for editions. For more information about all of the new features we added, you can see our documentation and news announcement on protobuf.dev. Thank you very much for your time. I hope this has shed some light on what we're doing with editions. Do we have time for questions? Do we have any questions?
Yeah, how are you planning to navigate this with manage mode and buff? Because like that pulls a lot of things out of the proto file for compatible. Oh, I can ask again. How are you planning to manage this with manage mode for buff for code gen? Because that like pulls a lot of options out into buff gen YAML, and it looks like this is pushing a lot of things into the actual proto.
I'm not actually familiar with manage mode from
Okay.
Buff. We can talk after. I'm curious about that.
All right.
Given that you have addition of the protobuf, like how it related to the gRPC because it generated from the proto C itself.
Sorry, what was that?
So what are related to the gRPC generator, like when you generate on the proto C, right? So
Yeah.
that addition is kind of like related to the gRPC when you release the new edition.
Yeah, so gRPC is implemented as a Proto C plugin. So it also has to advertise what editions it supports, but they're all tied together.
So you mean tie together when you announce like the new feature, it is gonna go to the protobuf, or it just have separate channel to check on the gRPC, like when we see the new
So
feature.
gRPC could introduce their own features, but for the global features, gRPC would have to respect those also. But at the moment, they're one of those plugins that don't actually care about any of the features we've released.
So that means we need to see on separate part, like on the edition of the protobuf and also something on the gRPC when we consider using the edition.
Sorry, I'm not following that.
So let's say like so something new on the gRPC, right? How can we know that like we use a specific feature on the gRPC and it not conflict with the edition on the protobuf?
What feature on gRPC?
Let's say like so I'm not quite sure between like the edition of the protobuf, right, and also the gRPC. So let's say you have 2024 of the protobuf, like so it does something new on the gRPC that we can leverage, and then we need to be careful like on top of that.
Yeah, so the edition only controls protobuf features, and gRPC could leverage that, but they're not at the moment. So the edition doesn't control anything that gRPC is doing at the moment.
Okay.
Thank you. Do you have any plans to build a language-specific API for Proto C, for the Proto compiler, instead of just utilizing the binary?
A language-specific API.
Yeah, like currently, if you want to compile a protobuf, you use the Proto C compiler, right? You have to install the binary. Are there any plans to bring that capability into any specific language as a library that you can build as code?
I see. So you mean you want to be able to build protos as a library instead of running
Correct.
the Proto C binary?
Yes.
So we do have dynamic messages in many languages, which can do something similar, but they generally can't generate code. Are you looking to also generate code?
Well, just basically how Proto C operates, but utilizing more of it in code rather than just the binary. So, for example, in our company, we're adopting more to be a polyglot. And so we want to standardize protobufs across different languages and how we use it internally, at least for Java, right? We have this protobuf and we build out this model and that we can consume it as dependencies for multiple different applications. But if we're dabbling in Go and Rust and other things, how can we what are the tools around being able to build those different models as libraries that those particular libraries can consume just from one protobuf?
Yeah, our general recommendation is to use Proto C as a parser, output it as a file descriptor proto, and then you can build that dynamically in all the languages separately using dynamic messages.
Okay. Okay.
And we're out of time.